Okay, so here's some practice on the volumes by cross-section worksheet. Basically, what are the two things you want to do is figure out it's perpendicular to what axis, try to give it a sketch so you have a better understanding, and then obviously know what shape we're dealing with. So let's look at number one together. It says the base of a solid is the region of the first quadrant enclosed by the graphs of. So they're talking about the first quadrant. So I'm just going to draw this off to the side, y and x. And I know that this is considered the first quadrant. They're telling you that you have the graph of that y squared. So we have that going on again. They tell me y equals 4. So we're looking at 1, 2, 3, 4. Y equals 4 is this line right here. They tell you x equals 0. Well, x equals 0 is right here. So the base is being formed, and they're saying the first quadrant, so we know this section here doesn't even exist, right? So the shape that we're dealing with, the base, is being formed by this, and by this. So we're just dealing with that as the base. Now remember, aerial view, and then they tell us that we're perpendicular to the y-axis. As soon as I see perpendicular to the y-axis, whoops, well then I know that it's going to be in terms of dy. So I know I need to integrate dy, and I know that my bounds need to be off of the y-axis. So my bounds in the first quadrant is going to be from 0 to 4. So okay, that's 0 to 4. And then I need to think about, well, the base, oh, they tell me the shape. The shape is a square. So I know the area is side squared. Well, this is the side right here. And I just need to find out, these are all the bottom of the side. Now think about if I just went ahead and created a square on top of that, right? With that being the base, right? Well, how do I find that side? This is where area between curves really helps. We know if it's in terms of y, it's not top minus bottom, it's a horizontal, it's right minus left. So my side is right minus left. Well, the right function is is y squared. So I'm going to say, okay, this is 0, 4, y squared minus, and then the left is x equals 0 squared dy. So this is my integrand. And if you see in number 1, they're not even asking you to figure it out. They just want to know the setup. Y squared minus 0 is just y squared, and then that squared is y to the 4th dy. So that would be choice E. Okay, so hopefully that made sense. All right, number 2, they say the base of a solid. So let me just start with a new picture here. At the base of a solid is a region bounded by, and they tell me the graphs of y equals square root of x equals 1, x equals 4, and y equals 0. What's the volume of the solid by the cross section? So I'm seeing volume and cross section, and then they tell me it's perpendicular to the x-axis and the shape is squares. All right, so shape is squares, which we've now been pretty comfortable with. It's perpendicular to the x-axis, so that's dx. I know that everything has to be in terms of x here, and the area here is going to be side squared. So again, give this a draw. So if I go ahead and I draw this out, this is my x-axis, my y-axis. Y equals the square root of x. Well, you know that looks like that. And they're telling you that it's being cut off by x equals 1 and x equals 4 and y equals 0. Y equals 0 is the x-axis. So this, looking at an aerial view, the side of the square is here, okay? Looking straight up, and then if I was to build a square here, that would be my volume that'd be created by that. So the square here is top minus bottom, which we remember top is the square root of x minus the bottom is 0 squared. So then I go, but what are my bounds? Well, it's from x equals 1 and x equals 4. So my final setup here would just be 1, 4, the square root of x. Now don't forget that's the side is this in red, but then I square it, so it's just x dx. And now I can go ahead and integrate it, and you know that's just going to become x squared times 1/2, and you're going to evaluate it for 4 and 1. You're going to plug in the 4 squared divided by 2 minus 1 squared divided by 2. So you're just going to get 16 over 2 minus 1/2. So I just get 15 over 2. So my answer is D. Okay, now we have one more to try to do together. All right, and this one says the base of a solid is in the region of the first quadrant. So again, they're telling me it's the first quadrant. They're telling me that it's bounded by this equation on the coordinate axis if cross sections of the solid perpendicular to the x-axis. Okay, so number 3, it's perpendicular to the x-axis, so I know it's going to be in terms of dx. They're telling me the shape is a semicircle, so I know that that is going to be pi r squared divided by 2 is the area. Okay, let's give it a draw. It's because they didn't tell me too many bounds, any information about bounds, so I got to figure that out on my own. So I'm just going to go ahead and go, okay, there's my y-axis, and there's my x-axis. And they're telling me that it's dx, so I want to go ahead and take this equation of 2x plus 3y equals 6 and solve in terms of in terms of x, so move the 2x over, 3y is equal to negative 2x plus 6 divided by 3, and it's a linear function, y equals, you get negative 2/3 x plus 2. So if I was to graph that line, here's 1, 2, that's the y-intercept, and the slope is down to over 3. So down 2 over 1, 2, 3, it stops there. And then this is the equation. Okay, well they said it's in terms of dx, correct? So that means that the bounds have to come off the x-axis, and they're telling me it's in the first quadrant. So it's from 0 to 3, and then you have to envision that right here, this is my semicircle, if I was to draw a semicircle right there, right? So you're going to say, well, this equation, y equals negative 2/3 x plus 2, well, that's the diameter of that semicircle, okay? So the radius is half of that, so I'm going to rewrite this as from 0 to 3. I'm going to say that this is pi, my radius is negative 2/3 x plus 2, that divided by 2, squared, divided by 2. So we got a little bit of a mess here, it looks like, right? Well, if I square this, I can rewrite this as pi, and I can rewrite this as negative 2/3 x plus 2 squared over 4 all over 2, right? And now remember, when you divide by a fraction, you just multiply by the reciprocal. So pi negative 2/3 x plus 2 squared over 4 times 1/2. Well, then I get that the integrand is going to be pi over 8 negative 2/3 x plus 2 squared, and I want to integrate this from 0 to 3. By the constant multiple rule, that can get pulled out, and I can now write my answer as pi over 8, 0 to 3, negative 2/3 x plus 2. squared dx. And that choice there would be, I believe, choice C. So this would be C. All right, so give the other ones a try, and we're going to meet on Friday to go over any questions you may have.